Hey guys, today we're looking at binomial expansion using the choose function. So, what you probably noticed when you were doing binomial expansion with Pascal's triangle was that if you had a big power on your binomial, you had to go pretty far into Pascal's triangle to get anything past the second term of that expansion. So, it got kind of annoying. So, there is a better way. It's called the choose function. Now, before we get into the choose function and exactly how it helps us find the stuff for the binomial expansion, I want to explain where the choose actually comes from. So, first of all, let's say that you are in an ice cream shop. Oopsies. And let's say that there are 8 toppings for your ice cream. And let's say that they let you choose 2 toppings. So in this case, n choose r is 8 choose 2. Now, what this is figuring out for us is how many different combinations of toppings could I choose? If there's 8 toppings and I can choose 2, how many different combinations are there? So, in our calculator, we're going to click on Math, go over to Prob, and then we'll choose 3 for NCR. So we want 8 choose 2, so we'll choose 8 choose 2. Really? Eight choose 2, and then we'll press enter. And we'll get 28. So that means there's 28 different combinations of toppings that I could have on my ice cream. So that's what the choose function actually is. Now, you'll see it written in a few different ways. So this first one, NCR, that's what we'll usually see here in the US. If you decide to go and take AP Stats, you'll probably see that there. If you are an IB, you're going to see it written like this quite a bit with that N as a superscript and the R as a subscript. IB will also show it to you written like this, where we have the N on top and the R underneath. No, there's no line in between it. It's not like a fraction. So over here, we have what it's actually equal to, if you wanted to figure that, is n factorial over r factorial times n minus r factorial, which is just really, really annoying to be able to have to find that by hand, which is why we are so lucky to be able to have our calculator there to use it. So here's what I would love for you to do. I showed you how to put that into your calculator earlier. Please go through and find what the values of each of these are. So remember, 5 with the 0, that's 5, choose 0. The 5 with the 1 is 5, choose 1. 5, choose 2. 5, choose 3. 5, choose 4. And 5, choose 5. Go ahead and in your calculator, figure out what each of those values are. All right, so when you put those into your calculator, you should have got 1, 5, 10, 10, 5, 1. And hopefully what you noticed from that was that it was the 5th row of Pascal's triangle. So we can use that choose function to help us find the coefficients on our terms of our expansion of a binomial. So here's that binomial theorem. We're going to have n choose 0. Our first term is always to the n power. And then the second term there, remember, I'm going to write it in yellow so you can almost barely see it. He's to the 0 power there. Plus, and then we'll have n choose 1 for our first term, a to the n minus 1 power, and b to the first power, plus n choose 2, a to the n minus 2 power, b squared, plus blah, 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 until we get to n choose n, b to the n power, because we don't have our a term there because he's to the 0 power. Now the reason I wanted to write it out like that was there's something I wanted to emphasize to you. Notice that whatever the power on b, oopsies, that's just a little bit too dark. Whatever the power on b, that's going to match my choose. So when it was b to the 0, it's n choose 0. When I had b to the first, it's n choose 1. When I had b to the second, it's n choose 2. When it's b to the n, it's n choose n. So whatever power on b you have, it's going to match the whatever choose that number on b. The other thing to notice here is that the n, what we always start with, is going to be the power on my binomial. So if my power is going to be 6, then we'll have 6 choose whatever the power on b is. So here's what that means. Each term in the binomial expansion is going to be n choose r, a to the n minus r, b to the r. Because remember, the powers on a and b have to add up to n before we simplify, right? So remember, n is the number or the power on binomial. This r and this r are the same r. Good deal. Okay. One other thing to notice is that this number right here on our C, we said that it matches the power of B, but also if you notice, my first term is n choose 0. My second term is n choose 1. So that number is going to be my term number minus 1. So let's take a look at what it will be for each term in the binomial expansion. So we'll have n choose r, a to the n minus r, b to the r. N is the power on the binomial. That r matches the r power on b, so those two things must match. And also, that is going to be, whoopsies, my term number minus 1. Fantastic. So let's take a look at this. We want to find the 7th term of the expansion a plus b to the 30th. So since a plus b is to the 30th power, that means that n is equal to 30. We want the 7th term, so remember r is the term number minus 1. So since I want the 7th term, r is going to equal 6, 1 less than that. So we are going to have 30, choose 6. We have A, B. We know that what we're choosing over here, choose 6, that's going to be our power on our B term, so he's going to be to the 6th. And we know that the powers on A to B need to add up to be 30, so 30 minus 6 is 24 on that A term. No, you are not allowed to leave it like this. You need to figure out what 30 choose 6 is. So that's what our calculator is for. We'll go to math. Oopsies, over to prob. Choose 3. And we have 30. Choose 6, I'm sorry. 6. Ooh, he's a big number. And we should be kind of expecting big numbers today. 7, 5. All right, so 593,775, A to the 24th, B to the 6th. All right. So in this next one, we want to find the term that contains x to the 5th. So here we go. We have in 2x plus y to the 20th. So that means that right here, n is equal to 20. So we know we'll have 20 choose something. All right, so we're going to have 2x here to some power. Now, it says that we want x to the 5th, so we want to take 2x to the 5th power. So then when we look at y, we know that these two powers, what's on 2x and what's on y, is supposed to add up to that power of 20. So 20 minus 5 is 15. So y is going to be taken to the 15th power. Now, since y is my b term, that means the power on y matches my choose whatever. So since I have y to the 15th, that means I have 20 choose 15. Now we're going to have to start simplifying. So in my calculator, I'm going to have to take 20 choose 15. But then also don't forget that to the 5th power goes to both of those things inside. So I'm going to have to multiply that by 2 to the 5th, x to the 5th. And then we have y to the 15th. So in my calculator, I'm going to put the numbers. So we'll go to math, over to prob, choose 3. You want to do 20, choose 15. And you can find out what that is, but I know I have to take that times 2 to the 5th. So I'm just going to go ahead and take that times 2 to the 5th power. And I'm going to go ahead and press enter. All right. 496,128. We have that as x to the 5th, y to the 15th. Okay, so now in x minus 2y to the 12th, we want to find the term that contains y squared. So first of all, we know that n is going to have to be 12, since that's my power on my binomial. So we're going to have 12 choose something. We'll figure that out in a minute. We know we're going to have x to some power. We'll figure out that power in a moment. And then we've got negative 2y. All right, so we want to find the term that contains y squared in x minus 2y to the 12th. So, first of all, we know that n is going to be 12. So we know we're going to have 12 choose something. We know we're going to have x to some power. And then we know that we also need to have negative 2y to some power. Now, since we want y squared, that means we want that negative 2y to be squared. Now, whatever the power is on my b term, so in this case, negative 2y, is what that r is going to be, right? So since negative 2y is to the second power, we're going to have n choose 2. Now I know my exponents on a and b need to add to be 12. So since my exponent on b is 2, that means my exponent on x needs to be 10. So here's what I'm going to have to put in my calculator. I'm going to have to put in that 12 choose 2. And then we'll have negative 2 squared in there, which is just 4. So we'll go ahead and take math, go over to prop, 3 for the choose, 12, choose 2, times negative 2 squared, or negative 2 squared is 4. We'll get 264. Right. So we got 264, then we have x to the 10th y squared. In this next one, we want to find the term that contains y to the 8th in 3x plus y to the 13th. So we know we're going to have n be equal to 13, since that's our power. So we'll have 13 choose something. We're going to have that 3x to some power and the y to some power. Well, we want y to be to the 8th power, so we know that this has to be 8. We know our exponents have to add up to the exponent on our binomial, so we want the powers on a and b to add up to 13. So that means the power on a has to be 5, because 5 plus 8 is 13. Now, in the 13 choose something, remember, whatever that something is, it's going to match the power on b. So that means that we're going to have 13 choose 8. Now, when we're looking at our calculator here, we're going to have to put in 13 choose 8. But then, remember, we also are going to have to take 3 to the 5th power. So in our calculator, we'll put 13 choose 8 times 3 to the 5th. Math. And we have 13 choose 8 times 3 to the 5th power. And we'll get 312,741. And then we have x to the 5th power, y to the 8th power. All right, good deal. See you guys later.